Let's go into our next module and kind of take it up a notch here. We're going to go into the advanced select statements. And in the advanced select statements, we're going to talk in here, as we move down through here, we're going to talk about things like the distinct clause, the aliases, scalar functions, using a case, joins and merges, we're going to introduce those, filtering data, sorting data, and how we work with the null values. So we're going to take down what we just introduced in Module 1, and we're going to take it up a notch and start working with some of these advanced options that we have available to us. And we kind of introduced a little bit, we did a little bit of the sorting and the filtering when we used the where clause already. Didn't do much with joins, but now we're going to talk about a few of these other more of advanced clauses that we can use with a select statement. Tobias, how does this distinct statement help me out here?
So distinct is all about removing duplicates in a set, and you typically use it for you want to list all of the first names in a table, and you have lots of Johns and even more Tobiases, because it's obviously a very common name.
Yeah.
So if you just say select first name from employees or whatever, we'll just give you all of the names in no particular order. But if you say distinct, we'll give you the unique combination across all columns. So that's an important thing to remember. Distinct goes across the entire row. It doesn't look at for a specific column. So it's across the entire row that you've selected, that you're projecting, and then gives you the result back without the duplicates. It's important to know that distinct is typically a fairly expensive statement to run. So the larger the set, the more work we have to do to remove these duplicates. It typically includes sorting the result first and then walking through and removing it. So kind of like you would imagine if you would need to remove duplicates from a set, you'd have to do something like that.
All right, and then here's an example of using a select distinct store ID. So if I just did a select store ID from sales.customer, it's going to display multiple occurrences of store ID. By throwing the distinct clause in there, now it's going to just show me every store ID, or it's going to show it just once, every store ID, which makes it, like you said, it's a little bit more overhead, but my result set's going to have fewer items returned to me.
Yeah, and it's important, this thing about performance, we'll probably talk a bit about performance over the day, but first comes functionality, right? You first need to get the results that you're actually interested in, and then you want to optimize this. And obviously, with regards to the results, the more you can constrain it and the more you can understand exactly what's needed, don't the more you can tweak the performance. But at the end of the day, you can't use a blanket statement like never use distinct, because if you don't want the duplicates in there, presumably you should use distinct.
Yeah, as long as you understand the overhead involved, like I said, there are going to be times where you're going to have to use it, but as long as you understand the overhead that's involved with that, you're going to be able to run with that. Here's some using aliases. Those help kind of format. Again, we're going to look at the different ways we can control the results in our result set. So we have column aliases here where we've got select sales order ID, unit price, order quantity, as quantity. So that's how it's going to display that. So this is adding an alias for a column by using the as clause. We can do something very similar by just using the new quantity, or the new column header. We put quantity equal order quantity. So we kind of flip these around without the as clause, where the new column header is to the left of the equal sign, as it is in comparison to the right of the as. You can also add accidental column aliases. I like this one. We have sales order ID, unit price, and quantity from sales.salesorder_detail. Notice I didn't put a comma after unit price. So this is why it's an accidental alias. What this will do is it'll actually give me content that is the unit price with the header of quantity. Is that the right order? Or am I going the other way? I can't remember. We'll see it. But
yeah,
because there's content in there without the comma, it's identifying quantity as the column header, but it's going to actually display the unit price in there.
Yeah, and it's so with regards to this, you may wonder, why do I have 3 different ways to do the same thing? Is it just that people are confused? No. So basically, as is what you should use. As is what is defined in the ANSI SQL standard. Why we support equals and basically without making as optional, so that's what you see at the bottom there, is because of legacy reasons. So one of the things that we do very well in SQL Server is keep backwards compatibility working for you. So basically, if we introduce something, even if it's a long time ago, you can still run the command today. The only time we go and remove it is basically if it's causing problems. So we highly recommend you use as that's the ANSI SQL way of writing it, but these other ways exist as well.
All right, so that makes it kind of the idea of aliases makes the column headers a little bit more manageable, because sometimes whoever designed the database may not have the most user-friendly column headers. Now we can define those a little bit differently. Aliases to refer to tables. You saw how we did that a little bit earlier. We've got select order, sales order ID, product ID from this table sales order detail as sales order. Now I can reference this table as sales orders in future statements here. This is similar to the columns. Now it's without the as. And then we have a table aliases in a select clause, and that's what we did earlier. There were my demo earlier. Once I define, or if I identify sales orders up here with the as clause, or if I use an as clause, I have to specify that in the select statement. So that's just the use of the tables as an alias.
So why would you use these table aliases?
Well, if we're going to talk about joins, if we're going to want to be able to reference maybe a table or multiple tables, or a table multiple times using different names, like within a join, these are going to be beneficial when we see the joins a little bit later.
Yeah, and it'll also help you from typing too much, right? If you need to reference this long table name all the time, it will help you if you use aliases and make them shorter.
Case expressions, a simple case expression, we'll talk about those. This allows us to compare a value to a list of possible values and then perform a statement based on the results of that. Case expressions may be used in your select columns, where having clauses, or your order by clause. And an example of one of these is shown here, where we have select product ID, name, and product subcategory ID, case product subcategory ID. When 1, then it equals to beverages, else it's an unknown category. So pretty much it's going to go down through, and when it finds that the product subcategory ID is equal to 1, we're going to know that it's beverages. Otherwise, it's going to show it as an unknown category. So when I do a demo, I'll show you this command specifically, so you have a better idea here as to what this looks like in action. In fact, let's do that now. So what I'm going to do is I'm going to go back into my image, and so I'm going to go in and I'm going to load a statement up, a query that I've written already. So you guys don't want to watch me fat finger everything. So I've got some statements here. We talked a little bit about the distinct here. We can just run that real quick so we can see that in action. So select distinct store ID. Let me grab this. Yeah, I'm okay. So we can run this one here. Click again. Here's the store ID is null. Then we start getting, wrong window. And then you'll see that we've got some, well, first off, let's look at this. We've got 711 rows. So if we ran this again, and let's just remove this temporarily, and then we run the same statement, and we return it. Now we have 19,820 rows. That's the idea of removing those duplicates that we discussed a little bit ago. So we can do that. These are the aliases. We've already seen these in action, so we won't worry about these too much. Let's go ahead and take a look at, here's that case statement. I want to show you that actually in action. So I'll go ahead and execute this. We already walked you through and talked about it. So we'll execute that now. And you'll see now we've got product ID. We've got name, product subcategory ID, so that's an unknown. If I scroll down, remember we're looking for a win1. So if we'll scroll down here, we can have multiple items here. You'll see now when I see number 1, we're getting beverages displayed. All right. Everything else, 2s, 3s through whatever other number, no values are going to display unknown category. So it allows us to control what's actually shown here when we're actually performing or creating or running a case statement. We can control what's displayed in that column.
And it's important to know that the case statement, so it's not a statement, it's an expression, it's a function.
Yeah.
So you can use it in any statement, more or less. You can use it in update, set something equals to case something, or in the order by clause, or in the group by clause, or in the on clause, or wherever. So it's wherever you can run a function, you can use the case expression.
Joins. Joins are powerful, maybe a little bit confusing sometimes. We're going to talk about joins next. And in the joins, we got a few different flavors of joins. We have cross joins, inner joins, and outer joins. And they can be a little overwhelming, but let's just as an introduction, cross joins combines all rows in both tables. Sometimes it creates what's called a Cartesian product. Inner joins applies filter to match rows between the tables. And then the outer joins display all rows from a designated table. And then it matches rows from the other table that's content's being retrieved from. So inner joins, as we just introduced, are just rows where a match is found in both tables. And an example of this is, let's start from the bottom. So I mentioned the idea of having an alias. So I'm going to just jump down to here where we've got from sales.sales order header as SOH. That's where the SOH is coming from. And then we're joining this a sales order detail as SOD. And then what we're going to do is we want to return content. These first two columns are coming from the header table. These remaining three columns are coming from the details table. So we're going to join the tables based on the sales order ID. They have to have that common column. They're going to join the tables on that sales order ID, and that's going to return the content or individual columns from both of those tables. Well, yeah, from both those tables in the same result set.
So, and as you can see here, it says join rather than inner join, and inner join is the default. So if you just say join, we'll go and do an inner join. The other thing is the on clause is the second filter clause. So after where, it's the first filter clause. So before where happens, on happens logically. And the on clause is just like the where clause. You could put basically any predicate in there. So it doesn't have to be join on the actual primary key, foreign key relationship. It could be join on this function of this column like something, right? That's whatever you put there. Obviously, the results may not be what you're expecting, but join actually fairly frequently. You can have lots of benefits from joining, not or answer interesting questions from your data without when you're actually not joining on the primary key foreign key relationship.
Now, what's the difference between an inner join and an outer join?
So, inner join, you get only the actual combinations across the table. Or the tables involved. So what you can look at it logically is you take two tables, right, and you get the massive set of all rows combined with all other rows, and then you apply the filter in the on clause. And obviously, if you apply this, you say this ID equals that ID, it will only return whatever rows are actually matching across these two tables. So what if, so an example would be, hey, Brian, please give me all customers and their orders. So you probably will join customer table with order table on customer ID, right? If I change the question slightly, and this is a good way also of kind of practicing SQL is actually translating a question in English or preferably Swedish, but where I'm from, to SQL. And so if I instead say, hey, can you please give me the list of all customers and their orders, and also include customers that don't have any orders, because those won't be returned if I use this inner join. So then I would instead, if I say from customers join orders, I would say left join, so left outer join, which is keep the rows that are not matching from the left table. So customers, you say first, that would be the left table, and orders would be the right table. So we have left join, keep from the left table, right join is just keep from the right table, and full join is also include orders that don't have a matching customer. That sounds like a referential integrity issue in this case, but that's basically the outer joins.
Okay, excellent. And this is an example of how a left outer join, as he just described it, would be written. So we're looking at customers that did not place orders in this case here. So this is an example of that command that Tobias just actually explained to us. Cross joins. Cross joins combine each row from the first table with each row from the second table. What does that give us? Cross join. I mean, we're combining all the rows from one table to the other table. Why would I use a cross join?
Well, there's not all that many reasons. You could imagine. So one thing is obviously just generating test data is very practical because you take one table with 10 rows, cross-join with another table with 10 rows, you get 100 rows back. But you could actually have an interesting example such as you have a currency table with all of the currencies and you cross-join that with itself. Now you get the product of all combinations of currencies.
All right, so not heavily used is what I heard, but it is nice to have it out there. So now we have a self-join. So self-join, compare rows in the same table to each other. Do I have an example of this? I do.
Well, that's all. The currency example I gave was an example of a self-join, but with a cross-join.
With a cross-join. So you can have self-join with cross-joins.
Yeah, self-join is just if you join with yourself.
What are the ones most commonly used? I would say the inner join, because that's the default. If you just type join, you get inner.
Absolutely.
And then your left and right outer joins, most likely.
Yes,
and
absolutely.
then your self-joins and your cross-joins, they're options, but probably not heavily used. We do have, as you can see here, examples available to you for how they would be written, but just to kind of give you some ideas on how they would be used.
Yeah, it's definitely in the order of inner joins and then left joins.
Okay.
And then full joins.
Well, let's just take a look at a few of these. If we can get just a couple of these to execute. And again, I saved you guys all of the headache of me fat fingering it and trying to type all this in. This is that statement that I created earlier, that I showed you earlier, I should say. Trying to get this slide down so we get a little, there we go. So this is the one that I had written earlier or discussed earlier. So this is that sample inner join. And as Tobias pointed out, I don't have inner join in there. I could make it a little bit clearer by putting that as inner join so you can see exactly the type of join it is, but it's the default. So we're going to go ahead and execute this. And notice we have our sales order ID. Remember, that's coming from the SOH, which is the order header. We have the order date. That's also coming from the order header table. And then we have 3 SOD columns to be returned. These are coming from the sales order detail. So product ID, unit price, and order quantity. These are being returned from the details. So it's a good way to take content that resides in 2 different tables. We join them on sales order ID. This in this case here, 43659, and return the results from 2 different tables into one result set. So it's good that we're able to do that, because often when we're working with relational databases, we're going to have content in multiple tables, and we're going to want to maybe return that content into a single result set. And the use of joins will help you perform that. Here's one more example we'll do with a join, and this is the left outer join here. And the left outer join is going to return all customers. Ooh, I just messed that up. Where's my undo in this thing? Undo saves me. There we go. So here's an example of a left outer join. Again, we saw this on the slide, but we have customer ID and store ID, sales order ID, and order date. And you can see here that customer.customer ID and store ID, these are coming in from the customer table. And then the ORD, which is the sales order header, is the sales order ID. So we're grabbing content from the left table or the first query in the statement, and we're adding additional content from the right statement. So just a quick example just to show you that those do run, and that when we're displaying them. So we just wanted to show you how those joins actually work for you when we're executing those joins. All right, so those are ways for retrieving content from inside of SQL Server, from different rows or different tables, if you will. We also have ways that we want to filter and sort data. And when you use the order by clause, I briefly did a demo of this already. The order by just sorts the rows, and it's just a way to make the presentation of the content easier for you. You want to be able to see sales order ID. We want it in order as an integer. Maybe we want customer by last name. You want to sort them alphabetically. Maybe you want order date. We want to know the most recent order or the order that was that came in the past. These are examples of order bys. So we're doing a select sales order ID, customer ID, and order date from the sales order header, and we're going to order it by order date. So we're going to give us 3 columns. So sales order ID, customer ID, and order date, and we're going to order it chronologically, I think is the right word, by order date. We can also go in and do a select sales order ID, customer ID. Now we're grabbing the year, and we're going to create a column, the year from the order date, as order year, again from the sales order header, and we're going to order by order year. This is an alias that we created because we're grabbing just the year from the order date. We're not worried about the time or the date.
So here there's something that's just worth mentioning that many people typically ask. So you can say as order year and then order by this alias order year, but you can't do it as order year and then in the where clause say where order year is equal to something. And that has to do with this logical query processing that we talked about earlier, because order by is the only thing that happens after select. So when order by happens, we know what the column aliases are, but when where happens, we don't know because select hasn't happened yet.
Great point. Definitely a great point. And the cool thing is we can reverse this. We've got the same, the top example here is order date. We could do in reverse order just by using the descending clause down here. And that gives us the same content, but in reverse order of the dates. So instead of the most recent, we'll have, or instead of the earliest one, we'll have the most recent one up top. We filter data using the where clause. That's one way that we do that. We've seen an example of that where we had all the rows being dumped out. A little bit overwhelming. So what we've gone here is we've gone customer ID, territory ID from the sales customer. If I just stop there and not have a where clause, every row is going to be returned from the customers table. Well, we're going to throw where territory ID equals 6. So I want to know where all the customers are that belong in territory ID equals 6. Or I don't have to use equal. I could say where territory ID is greater than or equal 6. So now I want all the customers in territory 7 through whatever number it goes through. We can also mix some of these up. On the bottom one, we talk about where store ID is greater than or equal to 1,000 and store ID is less than or equal to 1,200. So I want anything where the store ID, now I've moved away from the territory ID, the store ID is 1,000 or higher, but no higher than 1,200. So we want that, we've got that little gap area, or range that we want that store ID or the content for that store ID to be returned in. So again, it's controlling what's happening in your result set and how that content's being displayed to you. Other ways we can filter data. Maybe I want more controls. I don't want to see, every item. Maybe I got 100,000 or 500,000 rows, and I want just a portion of those rows. Well, what we can do here is use what's called the select top option, and we specify the number of items that we want to see. If I did this select sales order ID, customer ID from the sales order header and did order by total due descending, I could get 20,000 records. I don't know. But what I'm saying here is just give me the top 20. So this select top 20, I don't want 100,000 records. I want 20 records or whatever number I put in there. So I could change that to 50 and get the top 50 records. Now the thing with that is if I have 100,000 or 200,000 records and I'm trying to do this select top 20, what if I had 15 and there's 8 more that match? They're exactly identical. What this will do is select top 20 with ties. Now instead of just playing just 20, if it hits the 20, if there happens to be 23 because we have some ties, it's going to show you 23 items. Because it doesn't want to show you 20. Let's say for instance we have a salesperson and the top 20 salespeople in sales get a bonus. Well, if I just did a select top 20 and there were 25 people or 23 people that had the top sales, but I didn't put the with ties, there's 3 people that aren't going to get that bonus. There's 3 people that are going to be upset with me the way I wrote the code. So we can be careful about that. We can avoid information being ignored or not displayed by using the with ties option. We could just go a percentage at 20,000 rows instead of going a finite number of content rows being returned. We could just do a percentage of items that are returned. So if I have 20,000 items, I get 20 items. So don't hold me on the math, but so we'll have to see on that here.
So I'll show a bit of a demo I thought on top, because top is somewhat interesting. So if we switch over to my machine here, what I'd like to show is, first of all, you already saw top, right? We also have support now in SQL Server 2012 for offset and the fetch keywords, which helps you page through a result set, which is very common in web applications. So let's say I just go for production.product, and then I say order by, I don't know, unit price, or is it list price? There we go, list price. Now this will give me the full result set back. What I can now go and do is say, well, please offset 10 rows and fetch next 10 rows only. And that will actually give me the rows 11 through 20. right? And now I can go and say, you see the first one here is this chain ring, apparently. If I go and say, well, skip 20 rows, oh, it's still.
Still grab chaining. Or offset 20 rows, fetch next 10 rows.
That was in. Oh, sorry. So let's see here. Now there's something. So what's going on here? Well, these guys all have the same list price.
Oh, yeah.
So this is by accident. I showed you an even better example. This is amazing.
Exactly.
Oh, how good
Real
we are!
world.
How good we are, Brian.
That's
this
right.
this is really good. So here we see a problem that is common with basically both top and offset and fetch, which is what happens if I don't order by something that's unique. So let's go and add product ID in here, which will make some more sense. Now, okay, fork crown is apparently the top row, and then I'll go and say, well, 40. I'm jumping now forward.
There you go. Nice.
And you obviously can use variables and expressions, so I could say here at offset as I'm passing in. So that's one thing I wanted to show you guys, which is interesting. The other thing, which is a bit special, and we haven't talked about union because we don't have it particular in any of our slides, but union is the combination of result sets by concatenating them rather than join, which is combining them horizontally. So I have an example query that, let's say Brian just asked me, hello Tobias, can I please get the 2 most expensive black products and the 2 most expensive red products in a query? And you go, okay, that sounds like a reasonable question,
Ferrari
Brian.
and Lamborghini, I'm going to guess.
Yes. So I'll go, okay, let's get name and list price and color. It must be fairly boring product since they only have one color, but anyhow. And I probably want top 2, right? And then where color is equal to black in this case, and I don't know if black is actually a color and how that works, but at any rate. And obviously order by is important here, right? You say order by list price, descending, since we want the most expensive products.
Nice.
Okay, so that happens to be this Mountain 100 black.
I think it's a mountain bike or something, yeah.
Well, you never know.
Never know.
And then I also wanted the red product, so that seems like a separate query. So also give me the 2 most expensive red products. Okay, there we have those. And now this union clause would be very interesting because that's, again, just taking these 2 result sets and smashing them together. Mm-hmm. So I'll say union all. Union is implicitly a distinct, so you will automatically go and remove duplicates. That's per the standard, and obviously that's if you know there aren't duplicates between the sets, why pay the cost for doing it? So union all means don't remove duplicates. Actually, the select statement, you can say select all means the same, but no one ever types it. So select distinct and select all. So now we see there's a red squiggly here, right? So if I try this, it will start complaining and say, well, hey, Tobias, this doesn't really make sense. Because order by is at the set level. It's at the result set level. So what we're going to actually return. Okay, so we know. Whoa. Something happened on my screen.
I don't know. There we go.
Well, now we see me, but not the
We're
screen.
back to you. Can we go back to the demo?
This is... so now you can see me typing.
Yeah, right. Pretend he's typing the keys that you were just looking at.
Aha. Wonderful. Okay.
Here we go.
So, again, we saw this was the 2 most expensive black, and these were the 2 most expensive. So, about 3,000. So, let's just remove this order by clause.
Right.
And we now get something completely different back.
Nice, yeah.
And this is because of the logical processing of the query, right? Because first we go and do the from clause, the where clause, so we get all of the black products, and then we get just the top first 2 that we find, and then we'll go and do the same with the red products, the top first that we find, then we concatenate the result sets, and then we sort the result set. So if you turn on the query execution plan that we can find up here, this is something lots of people use to basically optimize their queries, but it can also be very useful to actually just understand what's going on. So if I look at the execution plan here, we can see we apparently go and scan an index here, which is the table, the clustered index. Then we do top immediately. Okay? There's no sorting that happens before that. Then we concatenate the result sets, and now we go sort based on color. So what I want to do is, instead of this, which actually is it's not a bug in the product, right? It's just the way that the language works. Instead, I can do, and this we will get into more details on later, but I can do a derived table here and say, well, from this select clause, now it's not ambiguous anymore, right? I'm saying, well, grab this result set. Right. Now it's the two most expensive black products, and then concatenate that with the two most expensive red products. We have to have aliases here on the tables or on these sets. And now we'll get the right result. Yeah. And now I can obviously also add an order by down here and say, well, I like to order by name. So that result set, I want those 4 rows sorted by name. So we get that back, seems to make sense.
Yeah.
And now the execution plan, we can see we have a different operator here, which is the now top sort operator. Then we concatenate, and then we sort the result set. Nice. So here we can just see what does union do, which can clearly be useful, and actually how top intersects with order by.
All right, excellent. Great demo. All right, so that's going to wrap up Module 2 here. We talked about the select statement. We introduced the distinct to reduce. There is some overhead involved, as Tobias pointed out to us, but the distinct removes those redundant rows. We introduced both column and table aliases. We talked about the case statement. We talked about the few different types of joins that we are going to be comfortable or need to get comfortable working with. Specifically, the default one is the inner join, and we have the outer joins. We looked at the order by and the where clause. We had a nice demo from Tobias on the union clause, and we also talked about the top clause in this area here. So let's go ahead and take a 10-minute break. And what we do when we come back, we're going to go into the next module. And when we go to the next module, we're going to start talking about some additional, again, more advanced topics when we're looking at ways for us to query content from SQL Server 2012.